and the video will be made available to you within the near future. Today we are joined by Daryl Kuda, Water Flow Meter Regional Manager. With that, I would like to welcome Daryl.
Thank you, Sharon. Hello, yes, I'm Daryl Kuda, Regional Manager with Teledyne ISCO. Thank you for joining me today on this important topic, eliminating risk when measuring open channel flow. This is a key topic for most of us. We all should be compliant with regulations and want to maintain a safe work environment. So if there is a safer, intrinsically safe option to eliminate risk and protect yourself when measuring open channel flow, why not use it? Today I want to go over an introduction to intrinsically safe equipment that meet the Class 1, Div 1, Zone 0, and ATEX 1G requirements. I'll talk about when intrinsically safe equipment is called for, why take the risk, where should it be used, and how does it work. And last, I'll finish up with the installation details showing you different examples of how to use the intrinsic safe equipment. First, let's start with an introduction to intrinsically safe equipment meeting the Class 1, Div 1, Zone 0, and ATEX category requirements. What I'm showing here is a control drawing that can be found in the Teledyne ISCO manuals for the intrinsic safe sensors and IS barrier. And what this is showing us is our classified locations and unclassified locations. And what that means is that over on the left side, the classified hazardous location is going to be your intrinsic safe sensor. If it's a ultrasonic sensor, a pressure sensor, area velocity, laser flow type sensor, all that equipment has to be intrinsically safe rated. And then to connect to a safe area or the unclassified area, you're going to use a IS barrier, an intrinsic safe barrier, to separate the two so you can connect it to a flow meter or logger, which I'll cover a little bit more later on in the presentation. So when is intrinsic safe equipment called for? Well, whenever a hazardous rating is required for a sewer manhole known as the NFPA 820. Essentially, every manhole is technically is a rated location. Now, Class 1 Div 2 does not quite meet that specification. You're going to find that consultants are more likely to specify products that are rated for NEC, CEC, Class 1 Div 1, ATEX applications. So why risk putting a non-classified sensor or flow meter in a location that has potentially hazardous gases? It may also be known as ATEX Category 1G, Zone 0 for international, or you may see it as the IEC rating for the international in Australia. Now, you may be wondering what some of these acronyms stand for. The NFPA 820 is the National Fire and Protection Agency, which states the purpose of the NFPA 820 is to provide a degree of fire and explosion protection. The equipment should not be the cause of any spark that could result in a fire or an explosion in the collection system or treatment facility. Now, the NEC is the National Electric Code, and CEC is Canadian Electrical Code, which use class and division to identify hazardous locations. Class 1 refers to flammable gases or vapors that are or may be present in the atmosphere in significant enough quantities to produce a fire or could ignite an explosion. Class 1 is further broken down into two divisions. Division 1 means that it has a high probability of the environment that could create a ignitable gas or vapor periodically. Now, Division 2 considers the flammable gases under abnormal conditions. So you should err on the side of caution and expect that hazardous gases are always there. Thus, that's why you need the Class 1 Div 1 specification. Now note the EX symbol in yellow It is recognized as the ATEX rated Zone 0. ATEX is an area marked as an explosive atmosphere or combustible gas, which could be dust clouds or mist, similar to the Class 1 Division 1. Now, ATEX is the acronym for Atmospheres Explosibles Regulations. It's a European Union standard for intrinsic safe products. The ATEX rating is a technical standard developed to minimize the risk of explosion caused by electrical or non-electrical equipment, such as flow meters, sensors in the wastewater treatment. Now, the different classifications for hazardous locations is going to be, you're going to hear intrinsically safe, where the power is limited so it cannot generate a spark. And the electronics, the design is taken into consideration. So what that means is that if the instrument was cracked open for some reason, it still would not produce enough current to create a spark. So even if you dropped a screwdriver inside the unit, it would not create a spark. So with no spark, there's no explosion. Now the other category is explosion proof. And what that is that any flame or explosion will be contained in a housing of the equipment. The design related to the mechanical enclosure is not the electronics. So what you're going to see is you're going to have like a big steel or stainless steel enclosure that if there was an explosion, it would actually contain it. So it doesn't stop it, but it contains it from spreading elsewhere. But what I'm concerned with today is going to be the intrinsically safe part of it. So where should intrinsically safe rated equipment be used? Well, the standard applies to the following. Primarily, the collection system is where you're going to see the IS equipment, combined sewers, wastewater pumping stations, wastewater treatment plants. And this is within certain areas of the treatment plant. Not everywhere in the plant is rated. Most of the time you're going to find that more towards the influent where you have a lot of the hazardous gases. So why risk it? So, you know, an area could be declassified, if things change where there's adequate ventilation through an area. It's not very often you see a site declassified, but possibly if some walls were removed and there's a lot of airflow through there, that could happen. But you still want to err on the side of caution by getting intrinsic safe equipment. Where else is IS equipment used? You're going to find it in industrial flow measurement. Hazardous material could be going through that sewer system, so if there's a chance for chemicals, petroleum, or other explosive material that could be going through the sewer system at an industrial application, that's where you would want to use IS rated equipment. So why take a chance if you don't know what's actually going through there? Now, not all industries are going to put out potentially hazardous gases. So it's going to be a specific site by site if you're going to need it or not, but it's something to keep in mind. Now, wastewater treatment plants have classified areas that I mentioned, and where you're going to find that is usually around the headworks, the grit removal, the sludge handling, digesters, and in the collection system. So pretty much everywhere up front where you could have gases build up that could potentially create a spark. Now let's go over some of the installation details and setup. There are two types of installations and setup. One is where all the equipment is located in the hazardous area. So your logger, your sensor, everything must be IS rated. Or the sensor is in the hazardous area, and but then you keep your electronics in the safe area, which would be separated by an IS barrier, which I'll show you some examples of that in just a minute. So first, let's cover when the entire system is installed in the rated area. The equipment should be rated for Class 1, Div 1, Zone 0, ATEX rated. And as we're shown here, the logger is IS rated, as well as the different sensors that you would mount into the collection system. All of our equipment has been third-party tested to make sure that it meets that qualification. It meets the IECEX international rating. And what we're looking at here would be the logger, a built-in modem, and the different types of sensors that can be used in the sewer system. Now the other option is the safe versus hazardous areas. So this is where you'd have an intrinsic safe sensor that you put in the classified area, and then you have a non-rated controller in the safe area. And so what we're looking at here is that down below on the right, the sensor is in the classified area. And whenever you have a pressure transducer, it needs to be vented to atmosphere in the hazardous area. So that's why we're showing here an air reference box. So it vents to atmospheric pressure in the hazardous area. And then the cable that's attached to it is a sealed cable. So that way, even if the cable was cut, we're not going to allow any of the gases to transmit through the air reference line. And so you'd run it through a conduit, which should also be sealed and goes to an IS barrier. Taking a closer look at that, here's our air reference box, as desiccant on there to reference to atmosphere. Goes through a barrier. Now the barrier can be mounted on a DIN rail mount next to your controller, or you could put it in another type of enclosure, but it needs to be separated from the actual electronics itself. And again, you can just refer to the control drawing out of any of the manuals to help you out with this. Now let's take a closer look at that IS barrier. So what we have here is the laser flow sensor, which is classified, connects to a barrier, which is clearly marked with the safe zone and hazardous. So make sure you connect it the right way. So the sensor would connect to the hazardous side. It's clearly marked as to where all the wires land. And essentially what the IS barrier does, it acts like a fancy fuse. And so what I mean by that is that if there was a power surge in the controller due to AC power surge or lightning or something, that the power would not be able to transfer through that barrier. It's going to hit that barrier, it would actually open up and then eliminate sending the power down into the sensor. So if we block the high current or power from going to the sensor, it eliminates any chance for a spark or explosion in the sewer. There's an example of where we have 9 of our signature meters installed, all with IS barriers and enclosures. And what they had done here is they'd sealed off each one of these conduits. That way no hazardous gases could reach into this safe area. Now the type of sensors that you can use, we offer the 310 ultrasonic sensor, the 350EX area velocity, and the 360EX laser flow. Now the ultrasonic sensor is rated class 1, div 1, zone 0. Now this is a level only measurement. It's commonly used with flumes, weirs. You can use it for overflow level measurement in your combined sewer overflows, tank level. So this is our standard sensor we've had for a long time, connects to our signature meters or the Dura tracker, and you would want to use an IS barrier to separate this from the controller. Now the 350EX area velocity flow sensor is also intrinsic safe, class 1, div 1, zone 0 rated. Now this has a pressure transducer, and what that's going to be used for is to calculate the wetted cross-sectional area in your channel or pipe. Use the ultrasonic Doppler for the velocity, and the good thing is there's no need for a primary device. You don't need the expensive flume or weir to install. You can install an area velocity sensor in most any open channel, round pipe, rectangular channel, oval, whatever it is. You can install that in there to calculate your flow. You're going to find the area velocity sensors are commonly used for inflow and infiltration studies, for temporary measurement. And then the sensors are great for the reliability and repeatability. And so you may find that if you need redundancy, you can mount two sensors in the same channel. They won't be affected. One little thing that a lot of people don't know about the area velocity sensor, we build ours with a temperature sensor built into it. And I bring that up because if you do have infiltration and you see your levels and your flows are going up, but your temperature is dropping, well, you know that you have rain infiltration. That's the root cause or the source of the problem why you're getting more flow. Now we'll just take a quick look at that. So here's an area velocity sensor mounted in a pipe. And to read flow, we just need to know the area and velocity to calculate flow. So we have a pressure transducer that's going to read the water depth to calculate the wetted cross-sectional area in your pipe. Going to transmit the Doppler signal, and it's going to read the frequency shift to tell us the direction of the flow and the velocity. So we'll read both direction and speed. And then with that, now we know the level for the area, the velocity, we can calculate the flow. And one question I get a lot is, well, what happens if the pipe goes surcharged or completely full? Well, your electronics are smart enough to know that you've hit 100% of the wetted area. And so then now we're just using the velocity proportional to flow to continue to give you accurate flow readings. Now, another way to eliminate risk is with the IS-rated area velocity sensor. Over here on the left, we're using a spring ring or a scissor ring to install the sensor. You can mount multiple sensors on that ring, or if you find you have a lot of debris covering the sensor on the bottom, you could just mount it over on the sides to keep it out of the sediment and debris. Another alternate method is over here on the right. This is our street level installation tool. So if you can avoid sending anyone into a hazardous area, this is a great tool. You just attach those pole sections to it, slide the ring down there. There's a nylon strap that you can pull on that. It will collapse the ring, slide it in the pipe, and then extract the pole section and leave it in place. And when it's time to remove the whole thing, that nylon strap, you just grab on that, pull it, pulls the whole system out. Now, other area velocity sensors are the laser flow EX non-contact area velocity sensor. It's also intrinsic safe rated, class 1, div 1, zone 0. It uses an ultrasonic sensor to read the level to calculate the cross-sectional area, uses the laser to measure the velocity. So again, there's no need for a primary device such as a flume or weir. You can use it for inflow and infiltration studies. It can be installed temporarily or permanent applications, and it gives you a high degree of accuracy with the laser flow system. Let's take a quick look at how that operates. So it uses the ultrasonic to read the level, which it'll determine the distance to the surface of the water, calculates the level. When you know the distance to the water, the laser turns on for 2 seconds, takes 5,000 spectral readings below the surface of the water because we're capturing the peak velocity, which happens to be just below the surface of the water. Now, all those three sensors that I had mentioned to you, they can be used with our DuraTracker. This is our new flow logger, and the blue case is our non-intrinsic safe, and the black is the intrinsic safe logger. And one thing to note is that all the EX sensors can be used with either one of those data loggers. However, if you have a non-intrinsic safe like the blue laser flow sensor, you cannot plug that into the black DuraTracker. It's keyed to for your protections. That way you don't accidentally connect a non-intrinsic safe sensor into the IS-rated data logger. Now the DuraTracker EX can be installed in the classified area. It has a modem built in, which is a huge benefit, because if you can avoid going into the pipe for any reason into the classified area, you can just call it up from your office, see what's going on, calibrate your level remotely through the modem. It has a low voltage operation, which we're using D-cell batteries. So we have a D-cell battery holder and or lithium-ion batteries to power the DuraTracker system. And then on the outside, there you'll notice there's an external plate, and a tool is required to access this battery compartment. The reason for it, we have the battery lock on there. It limits the battery change in the hazardous area. So again, we're trying to minimize risk by essentially requiring you to pull that the meter out of the classified area, set it above ground, and then you can pull the batteries out. So we want to eliminate any possibility for a spark. And as I mentioned, we're using the D-cell battery holders or lithium-ion batteries sold through ISCO. Now let's cover a couple of installation examples. I'm going to cover the intrinsic safe rated system within the hazardous area, what you can do if you need to extend your cable length, if an error reference box is used, and when you use the IS barrier. So first, let's look at the where the entire intrinsic safe system is within the hazardous area. As you'll notice, there's no error reference box needed. The ultrasonic sensor and laser flow sensor have a maximum of 108 feet cables for standard lengths. So the entire system will be mounted in the classified area, and the 350EX has a maximum cable length of 98 feet. But again, all this can just be set in the manhole, and then you'll have a modem on there so you can call it if you need to. The next thing I want to show you is same scenario, but with a error reference box. And so what we're using this for is just to extend the cable length. So looking over here at the right, we'd still have our 98-foot cable, and we're going to reference atmospheric pressure right at the air box. And then we're also using that as a junction box, and now we can splice up to more cable on there to go up to 900 or 492 feet. Same thing with the laser flow sensor, but we do have a maximum length of 108 feet, but it does allow you to extend your cable length if needed. And same with the ultrasonic sensor, maximum length of 492 feet. Now, the other reason why you need the air reference box is in this location, we have the area velocity sensor down at the bottom. We're going to vent into the hazardous area, the classified area, go through a sealed conduit, and then on up to the controller. And so that controller could either be a logger, like the DuraTracker, or a signature meter. And so we do need to reference atmospheric pressure within the sewer to give us an accurate level reading. Now, if over here on the left side, if we're still going to use the air reference box, so the laser flow sensor by itself doesn't have a pressure transducer, but in this case, we have a surcharge sensor on the bottom, which needs to reference to atmospheric pressure, go through the, once we're out of the hazardous area, then the IS barrier is required to connect to your logger or flow meter. Now, applications where the barrier or air reference box is not required is when you have the pressure transducer is not in use. So with an ultrasonic or the non-contact laser flow sensor, they're not using the pressure transducer. So no need for that box. Order the longer cable length, go into the safe area, install the barrier box, and go directly into your controller. Now, in conclusion, why take the risk when intrinsic safe rated flow meters are available everywhere? The world is changing and is recognizing the need for equipment that is properly rated for the environment. Multiple sensor technologies provide an excellent solution to any open channel application. A wide variety of electronics are available and compatible with multiple smart sensor options. So we do have the data logger, the Dura tracker system, or the signature. And the great thing is that you can use that same sensor with either system. And then we offer the cell phone communications, which is now available in the intrinsic safe equipment. We've always had it for a non-IS equipment, but now it is available. So it provides superior flow measurement while effectively transmitting the data to our latest cloud-based software, FlowLink Cipher. Or you can sit in your office, call up the sites, download the data, and it allows you to get alarming from the modems. And so if you have a high level, high flow alarm, you can have the instrument text you immediately to know that an event is occurring. So why not avoid the risk and just insist on flow meters that truly meet the intrinsic safe rating, Class 1, Div 1, Zone 0. Contact your local representative, or you can go directly to teledyneisco.com and see what we have available, and we would be happy to provide you with a safe, intrinsic safe option. Thank you.
Well, a big thank you to Daryl for sharing his expertise on this subject. And unfortunately, he is busy with another meeting, so we are lucky to be joined by Dennis McGinnis to answer your questions. So please submit your questions and Dennis would be happy to answer. Thank you.
Well, I just want to thank everybody real quick for joining us today. And yeah, so submit any questions you have to Sharon, and then she'll send those over to me and be happy to answer anything that Daryl didn't cover. But I will say Daryl did a great job. I think he hit everything, but obviously if there's something that you want a little more specific information about, I am definitely here to help you out. And I don't want to pressure anybody to, have to ask questions. So we'll give a few minutes here. And if there's no questions, that means Daryl, knocked it out of the park. So we'll just give a few seconds here to give you guys a chance to type up any questions you have. And in the meantime, I'll kind of sit here and try to fill up the space. All right, give a few more seconds here if anybody wants to write anything. Okay, we got one here. How does the AV sensor measure area if it is not mounted directly under the flow? Well, as far as the AV sensor, it would need to be underwater for it to actually measure any area for the flow. So I believe maybe we're talking about the surcharge sensor on the laser, where it is actually mounted out of the water. And so with that, how that works is that the laser will operate up until when the water actually does rise and it hits that. Once it hits that that sensor, then that's going to go ahead and that surcharge sensor will be underwater. Now it's going to click on and start measuring area versus the laser trying to measure. Let's see, it was mentioned that it can be mounted on the side to avoid sediment. Oh, okay, gotcha. So a follow-up to that is, what happens when we take the AV sensor and we offset it? So instead of being at the 6 o'clock at the very bottom of the pipe, we offset it, it's like at the 5 o'clock to keep it out of the sediment. So the idea there is, yeah, if the water level gets below the sensor itself, well, the sediment's actually going to keep a lot of that up. So that water level you wouldn't want that sediment to be part of that calculation anyway, because that's area that's not actually water moving. That's just well, sediment, mud and silt and whatnot. So we wouldn't record that regardless, but we would still only be able to record up until that sensor's underwater. So if we have that sensor offset 2 inches off the bottom at the 6 o'clock being 0, and 5 o'clock, let's say that's 2 inches up off the bottom, we would actually tell the meter there is a 0 level offset in the velocity setting where you can tell the meter that the sensor is 2 inches off of the bottom. Now that setting actually is just so the sensor knows when to stop reading velocity. Now we're still going to calibrate the level for the amount of water in the pipe. So if there's 5 inches of water in the pipe and I'm 2 inches offset, I don't tell the meter it's 3 inches of water over the sensor. It wants to know how much water is in the pipe. So I would still say 5 inches. That way, sometimes sediment, it does go away. You know, you get a good flush or whatnot, it takes away. But if it builds back up, and that's the idea, is typically you offset it when you have a hydraulic condition where you have a lot of sediment keep returning. So leaving it at the 5 o'clock position as our example, I would say that there's still 5 inches of water for my level calibration, but I would put the 2-inch level offset in there so it knows when the water level gets down to the 2-inch mark, it stops trying to read velocity. But anytime below that 2-inch mark from the bottom, I would not be able to read level from that point on. So you are correct. But if sediment truly is there, it wouldn't matter anyway, because that sediment would keep that water raised up when it is dry. So hopefully that answers your question there. Any possibility of powering the sensor using solar energy? Actually, yeah, the solar energy and the battery it's used on is actually on the outside. Now, this would only work if the sensor's on the outside in the safe area. Obviously, with the DuraTracker example, the intrinsically safe DuraTracker being down inside the manhole, those would only be battery only, the lithium and the D cells, like Daryl mentioned. But if it's an external, if you have it set up for the signature being outside in the safe area, if the unit is in the safe area, then we can power it up with the solar panels there. You still got your barrier block that you're gonna hit before it goes down into the manhole where your sensor's at. So yes, solar power would work as long as it's the application where the meter is in the safe area. If we have the DuraTracker down in the hazardous location, obviously no, we can't. We'd have to use batteries only. Do we recommend any specific batteries? Is another question. Right now, as far as the D cells, no. And the lithium, yeah, those you'd have to buy from us to make sure they're rated for inside the hazardous area. On the outside of the hazardous area, no. Whatever you want to do to power it, it's fine. Is there any SIL rating for the EX sensor? You know, I'm not sure. I would probably have to get back to you on that question. Is there any SIL rating for the EX sensor? I'll have Sharon write that question down in her notes, and we can get back to you on that one. Do any AV sensors need to be consistently submerged to maintain accurate calibration? The answer to that is no, but I can get back to, further on that. I've been struggling with a new AV sensor with the pipe, particularly has no flow. It has to be recalibrated. So in that case, no, the sensors actually, on our sensors, we just need a single good calibration to start with. So if that calibration is a dry pipe and there's no water in it, and I say the amount of water in here is 0, that's actually a valid calibration. If the pipe has water in it already and I put the sensor in, and in my example earlier, I was saying like there's 5 inches of water, I would measure how much water's in there. If there's 5 inches, I would tell it's 5 inches. As the water goes down and goes dry, that should go right to 0. If you are having a problem maintaining the calibration, especially in a zero pipe, one thing I'd make sure we would look at is the desiccant cartridge in the meter, depending on if it's the signature, it's in the far back left corner. There's a desiccant cartridge there. As far as the DuraTracker goes, they're the two spin outs, the little thumb screws you unspin and they pull out, and the desiccant's in there. If the desiccant gets plugged up, or if your hydrophobic filter gets plugged up, basically you're going to suffocate the area velocity sensor, and it's going to have a difficult time getting that the diaphragm to expand and contract as needed to atmospheric pressure, because now your desiccant there that's trying to keep the water or the air dry, the water out, if it becomes a plugged issue, then that's going to wreak havoc on the ability of your pressure transducer to operate properly. So yeah, if your sensor is constantly needing recalibration, I would say either we may actually have gotten water if we didn't stay on the desiccant and we got humidity inside the airline. What ends up happening is that airline inside the AV sensor is the size of like a pinhead. It's very, very small, and the reason we do that is because this thing has to have the ability to measure pressure down to a fraction of an inch of water pressure. So that airline is very, very small in diameter. so we can get that accuracy. The downside of that, it's very easy to get plugged. If we get humidity and we don't stay on top of the desiccant, if humidity builds up in that airline, even the residue of the water when it dries out, clinging to the side of that airline can cause problems. So we do need to make sure we stay on top of our desiccant in our meters when we're working, especially with those air type sensors with the AV sensor, because we have to make sure there's no humidity that gets in there. So imagine if a little bit of humidity got into that line, and maybe think of it as like a water slug. And so that little water slug's just moving up and down that line, wiggling back and forth. That's going to wreak havoc with the level calibration, in which case it's going to have a hard time staying calibrated. So I would suggest, you can always call in and we can help you with support on that. But at first, I would suggest changing out your desiccant cartridges, making sure that they're clean, the filters are clean, or even just taking the desiccant completely off the system as a temporary, just for a few seconds to let it see if it, even a minute, take the desiccant cartridges out. So if it starts working perfectly with the desiccant cartridges out, I would say those are definitely plugged and need to be replaced or cleaned. Plugging the desiccant cartridges back in, if it still and then starts going wonky again, then definitely it's in the desiccant cartridge. If you pull the desiccant cartridges out, again, off the signature or off the DuraTracker, and the problem still remains, it might be in the sensor itself, in which case my next suggestion would be, let's replace the sensor and see if the problem goes away. If the problem goes away by replacing the sensor, then yeah, unfortunately that sensor's probably been contaminated and there's not much we can do to get that stuff out of that line, so you're looking at replacement. Great questions, guys. Let's see, what else do we got? Let's see, I think that's it. I think we're all caught up. If you guys have any more questions, it's the time to do it. Otherwise, I think, yeah, it's been 2 minutes since the last question, so I think we're good. Or actually, it's been 6 minutes since the last question. So I think if you got any last minute ones here, send them in. Also, guys, the email, you can always send stuff to Sharon, myself, via email if you have more questions, or even Daryl, and we'd be happy to get back to you. Like I said, I will get back to the SIL rating for the EX sensor question. Other than that, if you have more questions, by all means, shoot us an email, and we'll get back to you with any questions you have. And with that, I'll let Sharon do the closing statement, and I just want to say thank you again for giving us your time today.